Now let's see these two examples. So two schedules are given. Now we want to test whether these schedules are view serializable or not. Okay. So now the first schedule is like this. So let me put it in the tabular form. See, in the exam you need not do it, but here it will be easy for me to explain if I put it in the tabular form. Now the tabular form is, for the first example there are only two transactions. So one transaction is first reading, read x, another transaction is writing, write x, and the other transaction is writing, write x, and now here there is abort, and here there is commit. Right, now this is aborting. So is there any need for this cascading abort? See, so no one is actually reading from what it is writing, therefore there is no need of any cascading abort. Right, now if it is going to abort, nothing is going to be changing. See, anyway this is a kind of blind write. In blind write, see, this one is going to read the data from the initial database and this one is going to write it finally. Now by having this write action here, the final value of x doesn't depend on T2, which means even if T2 wouldn't have executed according to this schedule, nothing would have happened. Therefore you can simply delete T2 because it is not required, and you can assume that there is only one transaction, and since there is only one transaction, it is conflict serializable as well as view serializable. Right. Okay, now the next one is example 2. If you observe it, let me write the tabular form for it. Now there are two transactions, T1 and T2. Right, in transaction T1 there is read on x, and in transaction T2 there is read on y, and in transaction T1 there is write on x, and in transaction T2 there is read on y. In transaction T3, there is one more transaction, T3. In transaction T3 there is write on y, and in transaction T1 there is write on x, and in transaction T2 there is read on y. Now let's try to find out whether it is conflict serializable or not. Right, so if we see it, whether it is conflict serializable or not, observe this one. So these two are saying that T2 followed by T3, and these two are saying that T3 followed by T2. Therefore definitely it is not conflict serializable because there is going to be a loop between T2 and T3. So you need not do it. See, if you are not able to guess it directly, you might have to draw the graph and you might have to do it. But since I am able to guess it, I am not drawing the graph. Right, now since it is not a conflict serializable schedule, can I declare that it is not view serializable? No, I need to test further. The next test is, are there any blind writes? Yes, there is a blind write here. Since there is a blind write here, we can say that we have to test further. Right, so what is the next test? View serializability. So we have to test for view serializability by using polygraph. So let me draw the polygraph for this. T1, T2, and then T3. Now if you observe it, the value of x is being read by T1 first. Right, and are there any read of x anywhere? There is no read of x. So the only transaction which is reading x is 1, and there is no write on x, doesn't it? It is only reading and writing x. Right, so there is nothing you can conclude from this. Right, either if T1 occurs anywhere, still T1 will be reading the value of x first. So you cannot put any edges based on that. Now let's look at T2. Now the value of y is first read by T2. Now what is the order we should enforce? Now if T1 happens first, then T2, then also T2 is going to read this one. Now if T3 happens first, then T2, then T3 will be writing the value of y from which T2 will be reading. So this should not be happening. Right, therefore now the T1 can happen anywhere according to this. Now according to this, T2 should definitely happen before T3. Therefore T2 should happen, then only T3 should happen. This is what I can draw. Why? If this is not the case, if I don't enforce that, then what happens is T3 might happen first, which is going to write the value of y, from which T2 is going to read, but T2 is supposed to read initially from the database, right? So this is how we should be writing it. And now let's see if there are any write-read dependencies. So if you observe it, the only write-read dependency here in this case is this one, right? So which means T3 should happen first and then T2, right? So this one is saying that T3 should happen first and then T2. Clearly these two are very important, right? See, T2 should happen first and then T3 because of this read action, that is why I have written this, and because of this write-read dependency, it is T3 should happen first and then T2. Now this is not possible, right? So according to the read action, T2 should happen first, and according to this write action, T3 should happen first, right? So both of them cannot be done in the same schedule, right? Therefore you cannot get any serial schedule which is view equivalent to this schedule. So we can say that this is not view serializable. Got it? So because there is a loop in this graph. Okay, fine.